Okay, so with proofs, there's no way that you do this without like reading and marking. So this is kind of cool because I've actually done it for you in this one. They're telling you TU is congruent to VW. So go ahead and mark that. Those are sides. So anytime you see this, that's a side. If you see this, that's an angle. Okay, so they're telling you TU, side TU is congruent to VW. TU, one tick, is congruent to VW, one tick. UV, two ticks, is congruent to TW, two ticks. TV is congruent to TV. Now, why is TV the same as TV? Because it's the same line. It's called reflexive property. It's just like you looking in the mirror and seeing yourself. You're the same person, so it's called reflexive property. Anytime you're talking about it without a number, it's going to be congruence. But when you're talking about it with a number, it's going to be equality. Okay, so it's reflexive property. Now, once you've done these three ticks, why are these two triangles equal? So if I drew one of the triangles on the side and labeled everything I had, why are they equal? Because I have a side, side, side. So these are equal because of SSS. So if I look for SSS. Okay, so again, you're proving these two triangles are the same. You're told that XZ is congruent to XY. XZ is congruent to XY, tick, tick. Angle X is congruent to angle X. Y is the same thing, because you looked at yourself in the mirror. Okay, so reflexive property of congruence. So why are the two triangles congruent? So if you highlight what you're given this, you're given that, you're given that. Start at one of the endpoints. So it goes side, angle, side, angle, side. So that's why it's congruent. Side, angle, side. Okay, complete this proof. There are three things that you're given. I don't have to read it because I can see the three things. I can see this is equal to that, that's 1. This is equal to that, that's 2. And then this is equal to that, that's 3. Those are my three things given. Then the question they're asking you is why, okay, why is WY, where's WY? Why is this equal to X plus Y? So where's XY. Why is it equal to this plus WX, this? So think about it for a second. Why is this piece plus this piece equals to the whole thing? Because of additive property of length. Okay, and then we don't care about the rest because they're not asking us about the rest. All right, complete the two proofs that they're, so mark down what's given. So the two triangles, or they're telling you the two triangles are congruent. So the two triangles are congruent. Then they're asking you then, why is TW, so TW, one tick, congruent to UV? Okay, well, if the two triangles are congruent, let's see which two triangles they're talking about. UVW. If this triangle, so if I take this triangle and put it on the side, is congruent to TWV. Is congruent to this triangle. Okay, let's put that one on the side. Okay. All right, so if they tell me these two triangles are congruent, then they're asking me, well, if they're congruent, why is this equal to this? Because they're the same triangle. Duh. So obviously it's because congruent parts of congruent triangles are congruent, which means every single part of this triangle is this triangle right here. So congruent parts of congruent triangles are congruent. Okay, so the biggest thing is you have to draw this. You have to label it. No way you do it without. All right, so there are three given things. They're not labeled, so now I have to label them. Angle FKG. FKG. So that's this angle. Is congruent to IHJ. Bam. GFK. GFK is congruent to HIJ. Bam. Given GH, tick, is congruent to JK. Bam. Why is it that GK, from here to here is equal to JK, is equal from here to here, plus GJ? Why is this added to this the whole thing? Because additive property of length. When you add part 1 plus part 2, you get the whole thing. Oh, I didn't finish. Oh, there's more. Okay, so then there's more. All right. So so now you have to go through it. And my markings are going to disappear. What do I do? What do I do? Okay, well, I guess there's nothing I can do. I just have to keep going. Y is HJ. So HJ is GH plus GJ because of additive property of length. Okay, I'm good with that. Then Y is GK is equal to GH plus GJ. Oh, because we substituted it. So let me see if I can explain that to you. This plus this is the whole thing, and then this plus this is the whole thing, right? So now they're saying that the whole thing here, you can say it's GH, GH, and GJ. GH and GJ, GH and GJ is HJ. Okay. If this plus this is the whole thing, and this plus this is this whole thing, what they're trying to say is that I could just substitute, basically this side is equal to this side. So Y is HJ, GK, Y is what was it? HJ. Y is this whole thing, this whole thing. Oh, transitive property of congruence. And then why are the two triangles congruent? So I've got two angles and a side. I've got two angles and a side. Two angles and a side is only going to be angle, angle, side, without even me marking it down. Okay, so just a quick note. Whenever you have three things, like you see 1, 2, 3, like they're all similar, and then the fourth thing, it's always going to be transitive property of congruence. And what that means is this. It's saying if 1 is equal to 2 and 2 is equal to 3, then 1 is also equal to, if 1 is equal to 2, 2 is equal to 3, then 1 is the same as 3. We're transferring. Okay. Oh, did I not? Transitive property? I thought I had transitive property. Oh, I hit congruence. My bad. Transitive property of equality. Because I'm dealing with addition.